Hello everyone. Today we'll be covering how to finally deploy your production code onto a real cloud server using the Google Cloud Platform. Before last week, we covered containerization and how to take your application code and containerize it using Docker and then push it to Docker Hub. And then we'll carry on this week covering how to take our image that's on Docker Hub and actually bring it onto a real cloud server and run the container there on a publicly accessible IP address to truly network our application. So all of this I'll be covering tonight is covered in the demo section of this week's chapter on deployment at our Backend course textbook. Without further ado, we shall begin, assuming you've already cashed in your Google Cloud credits, which are also present in the pre-class to-dos. But for now, we'll carry on, assuming you've already done that with the console. So also note that our Google Cloud credits are only granted to cornell.edu emails. And when you initially go to Google Cloud, it may be using your personal email. By default, just make sure to switch over to your NetID email so that you're actually on an account with credits. So the first thing we're going to do is actually start a new project. So we can start with selecting a project up in this top tab, and then we can select from Cornell EDU, or we can create our own new project, which is what we'll be doing today. So we'll create a new project. We can name it whatever we want. I'll be calling this one demo. It's under Cornell EDU, and this is all fine. You can leave as defaults, and we can create. Also note that some points in this process do take a couple of minutes to set up all of our server instances along this process, so I may be speeding up parts of this video or skipping to just avoid just people waiting around for things to happen. But for now, you can see we've created our demo project. So if we click here, it should bring us to our demo project. And then now what we're going to begin with is setting up our actual what's called a VM instance. So a virtual machine that'll be running some basic software OS. For us, we'll be choosing Linux. And then once we're in there, we can begin downloading our code and then running it. So we're going to start with this left side menu. We're going to scroll down to compute, and we want the compute engine. And then from here, lots of options, but we'll take the top one, VM instances. Again, VM stands for virtual machine. Oh, that's not good. Okay, sorry for cutting out, but now we're back. Something was going wrong with my credit redemption through the link. I'm guessing it's because I've done this multiple times, being an instructor last semester and a TA prior. So for me to get my credits, I just had to sign up for Google's free trial, which gave me $300 worth of credits, but also required me to put in my credit card information. So I'm just going to have to remember to get rid of that later. But if you are also encountering issues where this page isn't loading, because it's indicating you need to sign up for a free trial, I'd recommend just going ahead with that and making a note to yourself to cancel it later. You probably won't run out of credits. The $300 is a lot and goes a long way, as long as you remember not to leave your instance on all the time after the course. Even if you had it on from the day we set it up in this demo, you probably won't even run out of credits before the semester is over, so you shouldn't be too worried about that. But just make sure that you don't forget it. But continuing on, we have our compute engine, and we are going to create a new VM instance. So within here, name, it can be really whatever you want. I'm just going to call it, not name, demo. Labels, optional, region. I'd recommend putting this as close to you are geographically. So for me, I'm from the Bay Area, so I'll probably do, Oregon. US West. For many of you who are still in Ithaca or living on the East Coast, you'll probably want to do US East, whatever one. And honestly, really doesn't matter. Even if it's far away across the country, you'll still be able to connect to it just fine. But it's more of a matter of convenience of choosing your region. Then along with this machine configuration, we want to do a general purpose, and we want the smallest thing that, first generation, very small. And then here we go, machine type. So we want to go with the cheapest, which seems to be the G1 small, actually F1 micro. That's okay. It doesn't really matter. It's just all one CPU. These are going to be the cheapest for us. We'll just go with the G1 just in case. Our Docker images may be larger than 600 megabits, so might as well go up a little bit. But also, if you find that your images are too large, which they probably shouldn't be, feel free to expand upon your instance size. But G1 small should fit for our purposes. Moving on, we want to choose our boot disk. So by default, they choose this Debian Linux 9. We want to change that to an Ubuntu. And then we want to change it to Ubuntu 18.04. And then standard is fine. We'll select. And then we also want to make sure that we allow HTTP traffic. So Google by default sets up a firewall for us. Yep, by default all incoming traffic from outside is blocked, and we have to forcefully allow things to come in. Additionally, HTTPS, if you want a more secure HTTP system, you'll also probably have to set up like what's called an SSL certificate to actually make use of this, which implies you have to kind of like buy your own domain name and have that like registered officially. So we won't deal with that for now, but you can learn more about this on your own. But for now, we just want to make sure we're allowing HTTP traffic. Oh. And then from there, we can create our new VM instance. Once again, you have to provide a name, select your region, select your machine configuration, the type, make it small, and then select your boot disk to be Ubuntu 18.04 and check HTTP traffic. At this point, feel free to pause the video and wait for your instance to finish booting up. You'll know it's done once this row is checked off and you have all of these columns populated. But for us, we're now going to SSH into our instance via Google Cloud's web command line tool. So this SSH button connects. You can just click that, which will pop up a new window, which is super convenient that everything can be done within the browser for us. All right, I'll make this bigger. Once again, just giving us a bunch of info about what we just logged into. We don't really need to pay attention to it. But the big thing is that this command line functions pretty much exactly like a traditional command line on your own computer. So for example, we could do ls. We have nothing in this directory to show off. But what we're going to be doing is first installing Docker and Docker Compose onto our server, because this is in our local computer, just like when we needed to install Docker for ourselves when working with containers. We need to do that same process, well, a slightly modified process for this cloud server. So if you go back to the textbook, we have these links already there for you down under installing Docker and Docker Compose. So first off, we're going to follow this guide. Also note that we'll only be doing step 1. All right. So this is a guide written by DigitalOcean, very well-known, I guess beyond second to AWS, Google Cloud, and then like Microsoft Azure, but a good other cloud deployment setup you can use with them. But here they give us this nice guide on installing Docker on these machines. So basically there's just a bunch of commands down here for us to do and some guides, and we're just going to go line by line and copy and paste each one. So first thing to note, sudo and this cache symbol. So in our terminal, our cache indicates that we're not what's called a root user, meaning that we don't have all of the permissions to do whatever we want within this command line. We can forcefully override that by use of this word called sudo. I actually don't know what sudo is an abbreviation for, or what it like expands to, because it is a funny sounding thing, but it basically says, hey, for this command, give me all of the permissions to do it. Apt is Linux's package manager, just like how we use pip for Python management. Apt is Linux's general package manager. So the first thing we want to do is just update our Linux to make sure everything is good to go. Alright, looks good. Now we're just going to continue on, install some other things. Do you want to continue? So some of these command prompts will ask you for feedback before continuing. For everything, just type Y and then hit enter to continue. No, we want to try that to not come. Hopefully this process isn't too boring for any of you, but this does kind of highlight some of the deficiencies of this process and how manual it is. And in industry, a lot of this is kind of standardized or automated with other tools and startups that specifically work on solving, automating this type of process. But we're almost there. So now things look to be good, and then you can just hit enter. So now if we type in Docker, we can tell it's installed because we have all of these commands. Oh, where'd you go? Here we go, run docker command help for more info. So everything seems to be set up well for us, and now we can move on to install Docker Compose. But first, I'd like to mention that this step 2 is optional. You don't have to do this. And as it's saying, you can execute the Docker command without sudo. So in many cases, because we're not a root user indicated by this cache symbol, you'll need to use sudo before a handful of commands to force it to work. You can go through these to fix that, but personally we will not go through it because adding sudo isn't too big of a deal, and we'd like to just get through this. Alright, so next, after doing that, we can go through and install Docker Compose using this guide. Once again, from DigitalOcean, another great tool. Here we go. When we're checking the version of Docker Compose, you can see that it works if it gives you a nice version output after. And then we are all good to go on that. Cool. So now that we have Docker and Docker Compose installed on our external server hosted by Google Cloud, we can then move on to actually pulling our code from Docker Hub onto this machine. So we're going to start that actually through the Docker Compose file. So as you recall, back in the last demo, we showed you how to use a docker compose.yaml file to automate the running of your Docker container. So for us, just a quick refresher, Docker files, you define how you want to build your Docker images from Python 3.7s, indicating that we want to use a Python distribution. Running, making directory, and setting a work directory is just to clean up where we're putting our code. So if we need to go inside a container that's running, it's easier for us to find the code that we put there, copying over all the files in our current directory, installing requirements, and then when we run the container, the command that will be called is python app.py. So for us, this Docker Compose file only exists, well, it's part of the container when we build this image, but for us, we want to bring it onto our external server so to also automate how we're doing this. So for me, just to go over the Docker Compose file, the version you just want to set as 3, and then services allows you to define multiple containers to run at the same time. In our case, we only have one container to run, which is demo. We can name this whatever we want. And then within each service, we have to define an image and the port mapping. So the image for us is some username / some image name. Usernames are unique across Docker Hub, so this is how you uniquely identify a specific image on the hub. Also, what's going to happen is once we run a Docker Compose file, it's going to take this image off of Docker Hub and move it locally as well, so it's cached to make concurrent redeployments faster. And then a port mapping is what we allow to actually take in requests hitting the main server and map them into the container to be hit on our application routes. So for us, we make a Docker Compose file on our external server using this tool called Nano. So Nano is analogous to something like Vim, if you're familiar with like another popular command line tool, but we can create a new file using Nano Docker Compose.yaml. So whatever our file name wants to be, in this case it's that. So then for us, we can just continue with making our file. Actually, can we copy paste this? Oh, very nice. Cool. So that pastes nicely, which is good. And then for us, you can save by doing Control X and then save modified buffer. Just don't worry about it, just hit Y and then enter. We'll exit out. So now if we do ls again to look at the files in our directory, we can see we have this new file, dockercompose.yaml. Also to quickly talk about that port mapping real quick, realize we should go over that, is before last week we were doing a mapping of 5,000 to 5,000. So in this mapping, it's like the kind of like the environment of the command line of our like base server colon into the port within the container. So for us before we had a 5,000 to 5,000, but now we start with 80 to 5,000. So why do we switch this? So whenever we send requests to a server, we don't generally like to indicate the port in the URL heading. So before, like on Postman, you'd have to do like localhost, where's Postman? Say for example, like localhost colon 5,000. For us, when we have our front end send requests to the backend, we don't want to have to indicate this colon and then some port number each time. It's like overly verbose, and it's not generally regarded as a clean practice. So for us, port 80 is the default port for all HTTP requests coming in on a server. So what this will allow us to do is once we hit our IP, we don't have to provide a colon anything. We can just hit that IP address directly. And then that 80 will then map into the 5,000 of our actual container. So then now for us to actually run this container as we showed before, we can just do sudo docker compose up and then make sure you don't forget your -d flag. The -d stands for detached, so when we actually do docker compose up, it'll use the I guess like the tags that we defined in the file to run a Docker container and like that appropriate image and port mapping. And then the -d is a way for us to run this without occupying the current state of the command line, so that when we exit this window, it doesn't terminate the process and our code will still be running even after we leave. So if we hit this, we can notice it's trying to create a new local image for us, and it's going to be pulling our image. C Swinberg demo is what my account is, but so it's pulling here, and you can see each of these hashes represents a layer of the image that we initially pushed, and it's going to go through and pull each one as it goes down. So you may be wondering, like, why do we have so many layers? Like, we have a relatively simple application. It's because only, I believe, like no more than 3 of these are actually from the custom things we wrote in our Docker file, and the majority of these come from the base image we made from like Python 3.7. So Python itself has like probably comprises like 8+ of these image layers. Yeah, and that also means that as we show later in the demo, when we update our code and then repull it, we'll only be like needing to repull, say, like the top 3 layers, because the bottom ones will be staying the same from the Python distribution. So now for us, it's status downloaded newer image, and it created the demo, and it says it's done. So to actually check if a container is running, you can do ps, which will show you all the current running containers. And then for us, it gets a little bit wacky with these columns because the window's not wide enough, but you can see the image, C Swinberg demo, and everything status 27 seconds ago, and you can see the mapping here, 000, which is like localhost port 80, maps into 5000. So now what we can do is, back on our Google Cloud Console, we can look at our external IP. This is what is our publicly accessible IP address. So now if we click this, it'll launch a new window, and you can see here it actually sent a request to our IP. We didn't need the colon and a port because 80 is the default for HTTP, and then it returned us our data. For us, we have an empty database right now, which is why this is an empty list, but this is showing it works. Also notice that like this is automatically formatted because I have a Chrome extension called JSON Viewer that makes things pretty. I generally recommend it for just doing things with the web. But what we can do to test this even further is see if we can also hit it from Postman. So we can do this, IP, and then let's hit the tasks as well. You can see success data is true. So now let's actually try to send a post request and create a new task. So I believe task needs, we need a description and a done field. So let's add those. Description, make demo video. And right now we are in the middle of it. And then done is false. Come on, false. Cool. So now if we send this post request, it's going to say it's good. So then now say we want to go back to our web browser. If we refresh this, it'll make a GET request, and we can see, wow, it worked. Our application's functioning on a publicly available IP address that we can all mess around with. I'll also leave this IP address open for those of you to test it yourselves on Postman to have fun with it. And then I'll probably close it next week to save my credits. But for now, it's open. So this is exciting. This is like a pretty big deal. I remember when I first learned how to like set up a real container, it was like a big moment for me because this seemed crazy before taking this course, but now I guess we've walked you through this fun process. All right, so before we end, I want to also show you some handful of tips that can make your deployment life easier. And the first thing I want to go over is how to actually go through redeployment after, say, we've like made this initial deployment and we change some code to our application. Like, how do we update what's on the production server? So to test this, we'll say go into our code. Let's say we want to add something to like the base path, its own method. So say like def hello world. And we can just say return hello world. So this is just a basic example of what like a new route we may want to add or some other represented change, but we're just going to go with super basic for right now. Okay, so the first thing we need to do, this is my local terminal now. You can see I have all these files, but now the first thing I need to do is rebuild the image. So because we changed our source code, I need to rebuild a new Docker image, push it to Docker Hub, and then re-pull that new image off of Docker Hub in the external server. So we're going to do Docker build. I want to tag it as C.Swenberg demo. And then I want to build in the current directory indicated by a dot. So as we can see, when we are rebuilding, it's using my local cache of like the Python instance, Python layer, and then as it's going through each step, each line of my Docker command, it's using the cache. And then when it's running, installing the requirements, it's not reusing everything, but that's okay. But now we can see we've successfully built this. So now the next thing I want to do is Docker push this. Push this to Docker Hub. And then here we can see all of these layers already exist on that previously pushed image, and the only thing that's really changed are the top two layers, which make our lives a lot easier and faster. So we'll wait for this to complete through, and then check in on Docker Hub to see if it updated, and then carry on. Alright, cool. Looks like everything is good. So now if I go back to Docker Hub on my demo, we can see this was updated a few seconds ago, C.Swenberg demo. So now if we go back to our terminal shell and say we want to, so now we want to restart our server with this new image that's on Docker Hub. But for the first thing to start, our current image is now outdated, but it has like the same name. So the first thing we need to do is actually like stop running. Oh, here we go. See, now here I forgot to use sudo, so it's saying permission denied. So if you see that, just do sudo, and then we can do docker ps, and then we can see this is still running. So we want to lower this. We want to docker compose down to shut down this current instance so that we can pause to reset our image and then bring it back up. Also know that using docker compose down is what's called like the graceful way of shutting down a container. You can also use something called docker kill and then paste in the container ID if you want. That may be faster if you're impatient, but generally it's recommended to just let Docker do its natural process and take down the container that way. So now what we want to do is we want to sudo, that's not sudo docker pull, and then I want to indicate my image name. So C.Swenberg demo. Oh, that's nice spelled pull. Cool. Boom, as you can see again, reusing a lot of layers, pulling the new stuff. And then now we can just sudo docker compose up and then -d again. Says it's good. If we go now over here, so now when we refresh this page, because we're hitting the base path, we should no longer be triggering the get all tasks, and instead should get back a hello world. And as you can see, that's what happens, which is nice. But now say we go back and we can see our other stuff is still there. So /tasks. So now what we just realized is a big problem. What happened to all this data? Because that's not good. We don't want to redeploy our application and have it completely reset our database. So now if we go back to the cause of this, we can see that our current directory that we built from doesn't have like a database file, a tasks database. So even if we were to run our application, which would generate this todo.db file, when we would rebuild, it would continue to take the same database file and put it in the image that we would re-pull anyways, and it would still override. So our basic problem stays the same, where our todo.db file that's on the deployed server needs to stay the same. So we do this with what's called a Docker volume. So within our window here, So what we want to do is create a database file that exists outside of the container that we're going to run. Because ultimately what stays inside the container is what's going to get reset every time we update our image on Docker Hub and then re-pull it to run the new container. So what we want to do is create a new file. Okay, so here we're actually going to be using the touch keyword instead of nano to simply just create a file. So now we have like a to-do.db. So now what we need to do to update our YAML file is add what's called a Docker volume. So within here, just how we have defined our service demo and we have an image imports, we also want to add a Docker volume. So we can just hit enter and do volumes. And then here, the first thing we need to provide is our base path to our file that we want to identify outside of our container. So just how like port mapping is outside of the container to inside of the container, we want to do the same thing. So for us, we're probably gonna have to change this, but I want to say it's like home, and then we can just say whatever like directory it is. So we'll just say whatever slash to-do.db. And then we're going to use colon to map it inside. I believe our directory is user and then app, and then we want to map it into a to-do.db file here. So now for control X, yes, enter. Okay, so we're inside the squiggly directory. So if we go out, yeah, okay, it is home. Okay, and then we go out again. All right, so this is the root path. The base path is the slash. So where Google puts us is home, and then the user, for me it's CLS364, and then here we are. So if we go back into our Docker Compose, we want to change our absolute path to be /home /username and then /todo.db, and then that's going to map within the container user app todo.db, and we can check with our Docker file. Yeah. So here we make the directory user app at the base level, and then that's where we copy all of our code into. Cool. So now if we exit, all right, great. So now if we docker ps again, sudo. We have this image. We want to take this down again. And then what we're going to do is take this down and then re-bring it up so we establish that linking of the data volume between todo.db outside of the container to todo.db inside the container. And we can do, restart. Sudo docker compose up -d. Cool. So now if we go back to our instance, so no tasks, empty DB, base path still is the hello world. So now let's make a post request to create a new task as we did before. IP, tasks, body, cool. So now we have a new demo, a new task, tasks, cool. So now if we restart this process from the ground up, say we want to change this to hello world 2, and say redeploy everything, we can do docker build, retag it, and then push this image again. Oh my gosh, come on. Cool. Now going back in, bring this down. And then push it back up. Docker pull cswanberg demo sudo cool. So now if we do sudo docker compose, oh, forget all the tasks again. Now we can see this got updated and it stayed, and then we can see if this is still running the new code with hello world 2. So we solved our problem with the volume, which is fantastic. So now when we redeploy to the database, we're not going to reset our entire DB file because we've created the notion of a volume. And again, a volume, what we're doing is, oh, that's not what we want. Volume, just like a port mapping from outside of the container to inside the container, it's analogous for mapping files. So we can say, hey, use the file using the absolute path home, whatever your username is, and then the file, and then map it to the file wherever it belongs within the container. So for us, it's the user app directory, because in how we defined our Docker file over here, we made this new directory for our personal files and set that as the working directory within the app, within the container. Cool. So that's another good important fix. And then the third thing we wanted to go over is how to use environment variables within our code. So as discussed last week, an environment variable is important for when we build more complex applications that may rely on, say, other external APIs or other code bases that we need access to. So we use, say, environments for storing API keys. So for us, let's consider within app.py, we want to use, say, like an integration with, I don't know, we'll just make a general like secret key, but for example, maybe like the SendGrid API we had people do as a tier 3 challenge in assignment 3, 2 and 3, as well as like integrating with AWS for using like an S3 bucket. You also need your own secret key, but to use environment variables, what we need to do is import the OS library. So OS stands for operating system, and then we're going to set our secret key is going to be the os.environ. So environ is basically a massive dictionary that stores all of the environment variables. So it's like a key value pair mapping, and then so for us, we're going to set it. What we're looking for is something called secret key. So this will probably turn into some like long ass string that represents some unique key that was given to our user that we want to use within the application. So then here we can say back in this route, we can return secret key. You would never want to actually do this, but just for demonstrating that the key is actually being loaded in properly on the container, we're going to do it like this. And then for us, we'll set the secret key as some string. So then now here, what we want to do is we can make some environment files. So say secrets.env. Typically env is used to indicate that it's an environment variable, and that's how like our code actually identifies it. This is also regardless of Python as well. So we can go in here and we can do, say, not import, export. We called it secret key, and then say it's going to be, let's just say intro backend, spring 20. Alright, for us the key things to notice is we don't actually need to like put these in like quotations like we would for like a string in Python or another language. We're just blatantly writing down like the plain text, what the key is, and then what the value is, being intro backend for the value and the key being secret key. And then this export is something we need on our side for Python to actually identify this environment file with the os.environ package, but we actually won't need this once we go on to add this environment variable onto our container. But for now, that's all we need. Also, you could have made this file using like your IDE like Atom or say like Visual Code Studio, but for me I just did it from the command line just for fun. But now that we have this environment variable, what we want to do is also put it up onto our production server. So we can leave here and let's actually, oh, that looks funny. Huh, that was weird. Okay, but same thing here, we want to do nano and we'll do secrets.env, and then we can write out it was secret key equals intro backend spring 20. So here notice that we don't want to actually push this secrets.env file within our container when we build the image and then put it up to Docker Hub, because like mentioned last week, Docker Hub is a public repository, and just like how I could randomly SSH into a new server and pull that image, so could anyone else if they wanted to. So that's why we want to use environment variables through this more manual process of SSHing directly onto the server, because only we can do that given the authentication to like log into Google and so forth. But for us now, we define our variables, we can leave, and then now we can set our environment variable within the Docker compose file still. Very critical to note that like the compose file is super clutch for adding all of these things in one place versus using a Docker run command and then manually flagging all of these things like volumes and ports as we go. So here we can do, I believe, env file. And then for us, we can just say secrets.env. Yeah. And actually, I'll need to use an underscore here. Cool. So now we can leave. Cool, so now our compose file is ready. We have our environment file ready. All we need to do is re-push our code, our new application code that's using this now. So as before, if you didn't know before, now you know for sure. Docker build, tag it with your username and then image name, dot for current build directory. Cool, and then now we're going to push this image. Cool, we're all good to go. We can check again just for fun on Docker Hub. Make sure it was updated, which it was, and then back to our console. Sudo docker ps. We want to take down our existing running container with docker compose down. Repull the image. And then recompose up our container. Oh, wrong way. Now, if we refresh tasks, again, database is all good. If we go to the base path, it should be using our API key, which is intro backend spring 20. So this was manually populated back in our code with returning the secret key on the base path, and then secret key was imported through the operating system package using the environ variable, and then accessing the variable key, which is secret key. And then we established this just on our side with the secrets m folder, secrets n file, just for like our own development. I actually didn't show that like this was fine, but like it works. And then over here, we populated our n file in our Docker compose YAML file with that flag n file. So I'll show you one more time. N file, we set it as within our current directory secrets.env. Cool. So that's all we wanted to show you for deployment. This is all kind of the fundamentals of general deployment. Google Cloud is not the only cloud provider out there. Amazon Web Services is another fantastic one, along with Microsoft Azure and DigitalOcean. So this is just one potential setup. Also, Docker is not the only tool for containerizing and like running containers like this. There's another popular tool out there called Kubernetes that Google has just taken on as its own project recently. So this is just one of many possible ways to go about this, but we find this like the simplest way to teach new beginners, and it's actually like pretty much how we do it on AppDev as well. So hopefully you learned something. I'm pretty sure you did. This is a really cool thing, putting up your own IP out here. Very impressive, and hopefully you all have a speedy time on this assignment. But otherwise, that's all we have for you tonight. Enjoy.